All right, elimination level 3. So solving this system of equations, 2x plus 7y equals -5, and -x minus 6y equals 10 by combining the equations and then give the answer. Okay, so the first thing that we want to do is we want to hop over, let's see here, 2x plus 7y equals -5, -x plus, minus 6y equals 10. We're going to hop over to the sketch pad and get a fresh sheet going and start solving this system of equations. So I've got 2x plus 7y equals -5, and then I've got -1x minus 6y equals 10. Okay, so we have two variables that we could solve for, right? So there's two different ways we could approach this. We could try and get our coefficient in front of our x's to match, which probably would be the easier strategy in this case. And then we could add them down, add the equations together. Or the maybe slightly trickier strategy would be to get the 7 and the 6 in front of the y to match. So since we've done a couple of problems already where we've worked with just multiplying one equation, I want to show you now what it would look like when you have to multiply two equations, right? So what we want to look for is we want to look for a least common multiple of 7 and 6. And since 7 is prime, our least common multiple. I mean, you could, go off to the side. 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. Times 5 is 35. Times 6 is 42. Times 7 is 49, and so on, right? And then you could do the same thing. You could list out all of your multiples of 6, right? 6 times 2 is 12, times 3 is 18, times 4 is 24, times 5 is 30, times 6 is 36, and times 7 is 42, and times 8 is 48, and so on, right? And we would see, oh, hey, there's the first number that they both have in common is 42. Right? So I multiplied 1, 2, 3, 4, 5, 6. I multiplied 7 by 6 to get 42, and I multiplied 6 by 7 to get 42. So that's what I would do over here with my equations, right? I'm going to multiply my entire top equation by 6, and I'm going to multiply my entire bottom equation by 7, right? And we're allowed to do that because as long as you do multiply by both sides of the equation, you're using that multiplication property of equality, right? So let's see here. 6 times 2 is 12x, and then 6 times my 7y gives me 42y, and 6 times that -5 is -30. And then I'm going to do the same thing with that bottom equation, but by 7. So 7 times -x is -7x. 7 times that -6 gives me -42y, or -42y. And 7 times 10 is 70. And now we see we have matching coefficients on our y's, so we can solve this system by eliminating the y variable. So I have to think, okay, what operation would I do with a positive 42y and a negative 42y? Well, they're already opposites, so that tells me I want to add them. Okay, so if I add those, I'm going to have to add all the other like terms in my problem. So I've got 12x plus -7x, which is the same as 12 minus 7, which gives me 5x. I've got 42y plus a -42y, which gives me 0y. And -30 plus 70 gives me 40. 0 times y is 0. 5x plus 0 is just 5x equals 40. So I have now eliminated that y variable. I want to find what that x equals. So I'm going to get rid of that 5 by doing the opposite, which is it's attached by multiplying. So the opposite of multiplying is dividing. If I do it to one side of my equal sign, I have to do it to both sides of my equal sign. So 5 divided by 5 is 1. 40 divided by 5 is 8. So x equals 8. I'm not done. I need to make sure I go back and find that y value. You could pick either your top equation or your bottom equation. It really doesn't matter. I'm going to pick my top equation because it doesn't have as many negatives. I don't know. Maybe you pick your bottom equation because it keeps the numbers a little smaller. Either way. So I'm going to do 2. I'm going to take out my x and plug in that 8 plus 7y equals negative 5. 2 times 8 is 16 equals negative 5. Let's see here. I'm going to, now this is where SADMEP, right, comes into play. Reverse order of operations, okay, because we're trying to find what y is. So we have to get rid of the 7, get rid of the 16. So I'm going to get rid of the added or subtracted term first by doing the opposite, which is minus. So minus 16 to both sides of my equal sign. 16 minus 16 is 0 plus 7y equals negative 5 minus 16 is negative 21. 0 plus 7y is just 7y equals negative 21. I want to get y by itself. That 7 is being multiplied by my y, so the opposite of multiplying is dividing. If I do it to one side of my equal sign, I have to do it to both sides of my equal sign. 7 divided by 7 is 1y equals negative 21 divided by 7 is negative 3, so y equals negative 3. So my final answer would be 8, negative 3. And of course, it's always a good idea to go back and, check your work by plugging back in. So let's see here. I'm going to grab my second equation, negative 3 minus 6 times, I plugged my y in for x. I shouldn't do that. I want to plug my x in for x. So my x was 8. So negative 8 minus 6 times negative 3 equals 10. Right, so negative 8 minus 6 times negative 3 is negative 18. Negative 8, when you have two minuses like that, you're really doing a plus. So negative 8 plus 18 equals 10. And 10 is equal to 10, so huzzah! 8, negative 3 is my answer. And that is the harder of the two variables to eliminate for this problem. If you wanted the easier route, you could have just multiplied the second equation by 2, and then you would have eliminated the x variable first and solved to find y. All right, so let's plug this in, 8, negative 3, just to make sure we got it. 8, negative 3, oh, not negative 32, negative 3. Submit. Yes. Huzzah! Delta Math liked it. And that is elimination level 3.